Well, hello, Honors Algebra 2. Apparently in my last video, you had my voice, but not the correct screen. So we're going to try to fix that. Thank you to the alert students who brought that to my attention. So let's go ahead, and we are on page 469. We are technically, I think, looking at example 3, I think. I think that's where we are. So let's get rolling with that. I think what we're doing is evaluating logs. Okay, so it's going to say something like evaluate, right? Evaluate, and let's go with the log. So I've got log base 3 of 81. All right, so to evaluate a log, I'm going to try to figure out what power do I raise this base of 3 to get 81? So you're kind of working backwards in your head, but one of the first things that we can do is write it as an equation. Log base 3 of 81 equals some number y. And right now, later, I'll show you a way that we can evaluate this, but right now we don't know how to. So what we're going to do is we're going to rewrite it. Oh my goodness. That says rewrite. Rewrite in exponential form. All right. So the base is the base. And what is the log value in log form ends up being the exponent value in exponent form. This guy goes right up here. 3 to the y equals 81. The argument goes right here. Okay, so base, log value. So base, the log value in log form is the exponent value in exponent form. 3 to the y equals 81. Well, we've worked problems like this. We know that our exponential property of equality says when the bases are the same, you can set the exponents equal to each other. So I'm looking at this going, well, doggone, my bases aren't the same, right? So we're going to remember we rewrite the bigger base in terms of the smaller one if we can. And so you just think to yourself, hey, can I express 81 with a base of 3? And you can, right? Because 81 is equal to 3 to the 4th power. So we'll substitute that in for 81. Since they're equal, I can do that. So I have 3 to the y equals 3 to the 4. And now guess what? My bases are the same. So now I can set my exponents equal to each other. So that's my exponential property of equality that says I can do that, right? If b to the x equals b to the y, then x equals y. So if 3 to the y equals 3 to the 4, then y equals 4. And it does, okay? That is one example. Let's work another example, either when we've got a negative or an exponent, maybe a fraction. So I think I did one like that. If you need to pause here, you may. I'm going to go ahead. So I'm going to choose another page. And let's do another evaluate. Evaluate. Okay. So this is, let's see. Let's do one that's a fraction, maybe. So the log base 4 of 1 over 64. So log base 4 of 1 over 64. All right, well, we don't know what that is. The question is, what power do I raise 4 to? 4 to what power is 1 over 64? That's essentially what you're asking when you're asking about logarithms. Just like exponents are repeated multiplication, logarithms end up being repeated division. So log of 1 over 64 equals, we don't know. Okay, why? So I'm going to rewrite it in exponential form, b to the base to the y, essentially b to the y equals x. So I'm going to say 4 to the y power equals 1 over 64. We've done this. This is what our quiz was over. So now what? I want to put them in the same base. Well, can I rewrite 1 over 64 using base 4? And think about this. This is reciprocal. So when we've got this reciprocal, 4 squared is 16, 4 to the third is 64, but this is 1 over 64. It's the reciprocal of 4 to the third. So that what do we put on our exponent to get us the reciprocal? Do you remember? Yeah, negative, okay? So I can rewrite 1 over 64 as 4 to the negative third. So now I'm going to substitute that in. 4 to the y, that's a y, not a 4. 4 to the y equals 4 to the negative 3. And now my bases are the same, so I can set my exponents equal to each other, and y equals negative 3. Okay? Let's see if we have one more. Maybe one, that one had a fraction. I was going to maybe do one that was a negative, but I think that that's probably okay. So hopefully that helps for you to be able to do the rest of your odd problems. And I hope you have a great evening. And thank you for working and listening and not quitting, because remember, anybody can quit. Anybody can, but not you. You're not going to quit. You're not going to quit trying. All right? Great. Bye. Love ya. Shortcuts, and the shortcuts aren't working, so I have to